Okay, so in this video, we're going to go over solving quadratic equations by factoring. And the first thing we're going to go over is solving quadratic equations so that we are all sure of what we should expect when we are solving a quadratic equation. So when we are solving a quadratic equation means we've got an equal sign there. Okay, this is called the standard form of a quadratic equation, in which we put largest exponent down to smallest exponent. Now, some rules that you should remember from Algebra 1 about quadratic equations. It actually has something to do with when we study polynomial equations. There's something called the fundamental theorem of algebra, and a corollary to the fundamental theorem of algebra states that, so you don't know about degree yet, but if you have degree 2, that means you can have up to 2 answers, okay, or 2 solutions, 2 roots. So remember, you can have, for solutions, you can have 2 that are real, you could have 1 real, or you could have 0 that are real. Okay, so you can have 0, 1, or 2 real solutions when you are solving a quadratic equation. And it has something to do with the fact that it's raised to the second power. Okay, it also has something to do with the fact that this is the line y equals 0. How many different x values give you an output of 0? 2. Okay, 2 real solutions. How many different x values give you an output of 0? 1. This is 1 real solution. If you were to graph it, how many, this is y equals 0, how many x values on this graph have an output of 0? No real x values. Okay, so this is the reason, graphically, how we can show the types of solutions we can get. Okay, so what we're going to go over is solving by factoring only. And when you're solving by factoring, we're going to use a property in which I already discussed in a previous video called the zero product property. And what the zero product property tells us is, if we can get a product, okay, A times B, and it's set equal to 0, well then, if A equals 0 and B doesn't equal 0, A times B will equal 0. If A doesn't equal 0, but B equals 0, well then the product will equal 0. If A equals 0 and B equals 0, sorry if I messed this up, A can't be 0 but B is 0. If they're both 0, well then the product is 0. And that only works for when it's set equal to 0. Okay, no other number is this true. So if one of the quantities is 0, then the entire product is 0. So this product is used when factoring because notice, this is a product. Factoring is when you write as a product. So you use factoring to help you solve quadratic equations. So we're going to solve the following by factoring. Now the first one, I'm going to give you already factored. Okay, x plus 3 times x minus 1 equals 0. This is a quadratic, okay? It's got 2 linear factors. So it's a quantity times a quantity equals 0. That's what we need. It needs to equal 0. So if this quantity was 0, the entire expression would be 0. If this quantity was 0, the entire equation would be 0. So what makes x plus 3 equal 0? Negative 3. What makes x minus 1 equal 0? 1. So this quadratic has 2 solutions. Negative 3, 1. Number 2. Whoops. Okay. 5 times 2x plus 3 times x minus 4 equals 0. We see we have a constant factor times a linear factor times a linear factor. This is still a quadratic equation we're solving. Now, this time we have 3 quantities, but if you look at this quantity, okay, this quantity right here is a constant factor. This does not have the ability to change. So I can't pull out a value of x that will make this factor 0, because this can never equal 0. This is a constant factor of 5. So this does not have the ability to generate any solutions. But this has a variable factor. So what makes this 0 and what makes this 0? As long as the expression is set equal to 0. So take away 3, divide by 2, we get x equals -3/2. Add 4, we get x equals 4. We've got two solutions. Okay, so number 3, let's do, okay, x squared plus 3x minus 12 equals x plus 3. Super different than number 1 and number 2. But what I want you to look at is the ease of what we did in number 1 and number 2 came from the fact that what we had was a factored quadratic set equal to 0. So this is what we want to do. We want to make our equation equal to 0, okay? And then we want to try and factor the quadratic. So if we set this equal to 0, that's going to give us x squared plus 2x minus 15 equals 0. So now, notice we could generate up to 2 answers here, okay? Right now, the only way we have of figuring out those 2 answers is if we could break it down into linear factors, we can grab a solution from each factor. So we look at this, okay? This is our quadratic trinomial. There's no GCF. All right, but I can use the AC method here, okay? A times C is -15, B is 2. What two numbers multiply together to give you -15 and add together to give you 2? That's going to be 5 and -3. So this is going to be x squared plus 5x minus 3x minus 15 grouped together, right? So this is going to be x squared plus 5x plus -3x minus 15 equals 0. So it's going to be x times x plus 5 minus 3, or plus -3 times x plus 5. Take out the greatest common factor. Oh, I don't need to put these. We'll put this equals 0 back in at the end after we factor the left-hand side here. So it's going to be x plus 5 times x plus -3, or x minus 3. Now we can put back in that equals 0. So now what we were able to do is we were able to take the standard form of this quadratic expression and write it in its factored form, which now allows us to use the zero product property. What makes x plus 5 equal 0? What makes x minus 3 equal 0? That's going to be -5, 3. Okay? So when you get to equal 0, you look, this was a quadratic trinomial, so we tried the AC method here. Okay, so 3x squared plus 5x equals 2x plus x. Oh, sorry, 2x squared plus x. So what we're going to want to look for here is making sure the first thing when you're solving, okay, notice, you know it's a quadratic equation. You've got a quadratic expression. You want to set it equal to 0, okay? You always want your to be one side of the equation to be 0. So I'm going to take away 2x squared from both sides. I'm going to take away x. That gives me 3x squared minus 2x squared, that's 1x squared. 5x minus x, that's positive 4x, equals 0. So the first thing I look for, I see this is a quadratic, okay? It's not necessarily a quadratic trinomial. I could make it a quadratic trinomial if I put a constant plus 0 there. However, let's look at what we've got. We've got a quadratic that has a greatest common factor. So if we factor out the greatest common factor, which is x, we're left with x plus 4 equals 0. Is there anything left to factor in here? No. Now, this is a linear factor of x. This is a linear factor of x plus 4. This factor outside here is not a constant factor. It is a variable factor. What makes x equal 0? Well, 0. What makes x plus 4 equals 0? -4. So your two answers here are 0 and -4. When your greatest common factor involves a factor of x, one of your solutions will always be 0. Okay, let's go over one more. Okay, 2x squared minus 10 equals 15 plus x squared. So we want to set this equal to 0. So we're going to take away 15 on both sides, take away x squared on both sides. So that's going to give us x squared minus 25 equals 0. So we check. Now that it's a quadratic set equal to 0, first thing we look for is there a greatest common factor? No. Greatest common factor there is 1. Is this going to be factored using the AC method? No. Could this be the difference of two squares? Ah, yes. We might be getting our 2, 1, or 0 solutions using difference of two squares. So we look, can we write this expression as something squared minus something squared? Yes, we can. That means this can be factored using the using difference of two squares. So this would be a plus b times a minus b, which is going to be x plus 5 times x minus 5. Okay, there's a different property we could use, but that'll be in a future video. So, what makes x plus 5 equal 0? -5. What makes x minus 5 equal 0 when x is 5? So, we got two solutions again. One solution is going to come from if these were the same factors, okay, you're going to generate the same expression twice. And you're not going to be able to see no real solution yet when we do solve by factoring because of a property in which you won't have any real numbers that you would be able to generate. Okay, so that's it. Make sure solving by factoring, the big thing is make sure you set it equal to 0. And then look at through your methods of factoring the quadratic in order to get it as a product of linear factors.